So we know the relationship between power and voltage, power and current. Okay. So we know that power is equal to V square over R, that is equal to I square into R. So this relationship we know. Okay. Suppose if you have a waveform, okay, if you have a signal f of t and the corresponding Fourier transform is f of omega. Okay, how do you calculate energy or power? Okay, that is a problem here. So in time domain, in signals and systems, okay, you will study in time domain. If you want what is the power of the signal, so what you can do, you just take square of that signal, integrate from minus infinity to plus infinity dt. This will give the power. Okay, so this f of t can be a voltage waveform or it can be a current waveform. Okay, that you just understand, it is v of t or I of t. It can be a voltage or it can be a current. Okay, generally I wrote f of t. So for a signal, if you want to find out the power, this is the way. Okay, energy or power, you will be calculating like this. Okay, in frequency domain, you will do the same operation, f of omega. You will not directly square. Why means this f of omega is complex in nature. So you are taking absolute and you are doing square. Since this is in the frequency domain, you are integrating with respect to omega. You are integrating with respect to omega. So and since we are operating in omega, there is a scaling factor 1 over 2. Okay. So kindly note down, this is the energy expression in the time domain. This is the energy expression in the frequency domain. So there is a theorem called Parseval's theorem. Okay, Parseval's theorem. What it says, you calculate the energy in the time domain. You calculate the for the same signal. For the same signal, you calculate the energy in the frequency domain. It says that both are same. The meaning is, if you convert the signal, if you transform the signal from one domain to another domain, energy is not reduced. The same energy is retained. That is the theorem. Okay, that is the statement of this theorem. So you can note down what is Parseval's theorem. Okay, we are going to prove this. I said this f of t can be a voltage, it can be a current. So in some problems, they take the resistor value to 1 ohms. So if that is the case, voltage and current, it can be a voltage or current, P is equal to just V square or I square, no problem. Suppose if they have given some resistance value, if the waveform is voltage, so what we will do, we need to divide this by R. The same thing we will be doing here. If f of t is voltage, then energy is this entire thing divided by R. Similarly, in the frequency domain also same thing. If it is current, this entire thing is multiplied by R. Okay. So these expressions are developed by assuming that R is equal to 1 ohm. So the basic expression, whatever I wrote initially, that is developed by assuming that R is equal to 1 ohms. These things you need to keep in your mind. We'll go for a very basic example. Please note down this question. we are going to verify Parseval's theorem. Okay, the voltage across a 10 ohm resistor is 5 e power minus 3t ut volt. Find the total energy dissipated in the resistor. So what we are going to do, we are going to solve the problem in time domain. We are also going to solve the problem in the frequency domain. We are going to show that the result is same. Okay. In this question, if you notice, R is equal to 10 ohms. So first, let us solve this problem in the time domain. Okay, we'll solve this problem in the time domain. We know the energy, okay, across this 10 ohm resistor, energy dissipated across this 10 ohm resistor is, okay, integral minus infinity to plus infinity v square t dt. Okay, and you just see this is the resistor value is not unity, so this value, this entire value is divided by 10. This is what the energy. So I'm writing this 1 over 10. Let us write as 0.1. Okay. What is V of t? Okay, V of t is 5 e power minus 3t u of t. But we know that this u of t is valid from 0 to infinity. For negative values of time, this is 0. So what I'm doing, I'm just considering only the positive integral, positive limits, 0 to infinity, 5 into e power minus 3t, the whole square into dt. Okay. So in next step, 0.1, integral 0 to infinity. If you square this, you will get 5. If you square, you will get 25. If you square this e power minus 3t, you will get e power minus 60 dt. Okay. Is this clear up to this?
Yes, sir.
Okay. Now this 25 also you can take it outside. 25 into 0.1, it's 2.5. Okay. If you integrate e power minus 60, you will get e power minus 60 over minus 6. The integral limits are 0 to infinity. So minus 2.5 over 6. When I substitute the upper limit, e power minus infinity, it is 0. When I substitute the lower limit, e power 0 is 1. So this is 2.5 by 6. This entire thing is 2.5 by 6. Can somebody calculate this and tell the value? You just verify, is it 416.7 millijoules? Since it is energy, I am writing this in terms of joules. Just verify the result.
Yes, sir.
Yes, sir.
Okay. So time
Excuse me,
domain.
sir.
Yes.
Why did we change the integral from minus infinity to 0?
See, what is the input signal? 5 e power minus 3t u of t. What is the support of u of t?
Oh,
For
it will
negative
be
values
0
of time, it is
in the-
0. Okay.
Okay, sir. Yes.
Next one. We'll try to find out the energy in the frequency domain. We'll try to find out energy in the frequency domain. So V of t is given to us. It is 5 e power minus 3t into u of t. So if you take Fourier transform for this, you'll get 5 over 3 plus j omega. But if you look at this expression, we need absolute V of omega the whole square. Okay, absolute V of omega the whole square. So absolute V of omega, the whole square is, shall we write like this, V of omega into V conjugate of omega. V of omega is 5 over 3 plus j omega multiplied by V conjugate of omega. Wherever the complex number is there, you just make j2 minus j, so you will get 3 minus j omega. This if you multiply numerator 5 into 5, 25. This is something like a plus b into a minus b. So 3 square, it's 9. J omega the whole square is it omega square?
Yes, sir. Plus omega square.
Plus omega square. So 25, 3 square 9. Okay. 9. So this is absolute V of omega the whole square. Let me write this result, note down this result. Okay. Now in the frequency domain, the energy is energy across this 10 ohm resistor. It is 1 over 2 pi integral minus infinity to plus infinity absolute V of omega the whole square T omega divided by 10. Okay. So this 10, if you take it to the numerator, you will get 0.1 over 2 pi. See what I can do, I can write this integral something like 2 times 0 to infinity. Okay, 2 times 0 to infinity. If you plot, okay, you can show that this is symmetric. You can write, okay, instead of minus infinity to plus infinity, I'm writing 2 into 0 to infinity. Let me substitute if you want the 25 also. Maybe in next step I'll write 25 by 9 plus omega square d omega. Okay. So you have 0.1 into 2 into 25 divided by 2 pi integral 0 to infinity 1 over 9 plus omega square d omega. I want to use a trigonometric relationship. This you might have studied in some mathematics course. Integral du divided by a square plus u square is
tan inverse
1 over a. Very good. Tan inverse
u by
u by a plus c. I put a box here. So this is something like 1 over a is 3. You just assume a is 3. So a square is 9. So this is with respect to u. Here we are writing with respect to omega. So let us try to simplify this. See, if you want, you can simplify this and you can keep it as a single term. Okay, I'm not doing that. In this case, a is 3. So it is 1 over 3 tan inverse omega over 3. The integral limit is 0 to infinity. So somebody simplify this, all these terms. Okay. So if you substitute infinity, upper limit, tan inverse infinity,
Pi by
you know
2
that
max.
it's pi by 2. Tan inverse 0, it's 0. So can you simplify this first term, or can you simplify the entire thing and give me the result?
5 by 12.
Is it
Yes.
the same answer?
Yes, sir. Same.
Yes, sir.
Yes, sir.
So the inference here is, if you transform the signal from one domain to another domain, okay, time domain to frequency domain, okay. So whatever the energy, that the energy of the signal that is there in the time domain, the same energy is retained after transformation also. The energy value won't change. So that is what we have proved here. We took a simple problem where V of t is given and the resistance value is given as 10 ohms. We try to find out the energy value in the time domain. We also found the energy value in the frequency domain. Both the values are 416.7 millijoules. So energy value is not altered in time domain and frequency domain for a particular signal. Okay.